In this video, we're going to talk about how to do a confidence interval for a population proportion, which we call P, and then we'll actually construct a confidence interval for a population proportion, which is very simple to do in the graphing calculator. And you'll see as I'm going through some of the slides that there are certain steps on here that we actually don't have to worry about because the graphing calculator will just take care of it for us automatically. So a population proportion is the probability of success in a binomial experiment. In other words, basically the reality is what is the likelihood that something actually happens, okay? And we denote the population proportion by the letter P, not to be confused with p-value. So this is actually a bolded P. And basically, the point estimate for a population proportion is basically just a sample proportion. So we might want to know, or we might, here's an idea, or here's an example, excuse me. We believe that 7 out of 10 kids brush their teeth once a day. And if we're not going to be able to ask every kid how many, if you brush your teeth once a day, but we could get a sample of students, and ask them, how many, do you brush your teeth once a day? Yes, no, and we can get a sample proportion that way. And we denote a sample proportion as P with a little caret over it. We call that P hat, which is basically a simple fraction of x over n. X represents the number of successes in a sample, and n refers to the sample size. So in other words, in the case of the kids brushing their teeth, okay, that would be, x would be how many of the kids in your sample say they brush their teeth once a day, and n would refer to how many kids did you ask, period. And there's just a little chart. Sometimes in stats, if you're doing a confidence interval by hand, you also need to know what Q is. Q is basically the population proportion of failures. So in other words, how many people don't fall in a particular group. So for example, if we believe 7 out of 10, 7/10ths of all students brush their teeth once a day, then Q is going to be 1 minus 7/10ths, which basically is the proportion of kids that don't brush their teeth once a day, which would be 3/10ths. And we call that Q hat. Now, when you're using technology, you don't actually have to hand calculate Q hat. It's one of those things, as long as you give the calculator what P hat is, it'll do Q hat automatically for you. In a survey of 1,000 U.S. adults, 662 said that it is acceptable to check personal email while at work. Find a point estimate for the population proportion of U.S. adults who say it is acceptable to check personal email while at work. So basically, what is the sample proportion of people that check their email at work? So that's literally the 662 that said that they did out of the 1,000 people that they asked, and you can write it either as 662 over 1,000, or you could take it one step further and write it as a decimal, which is 0.662, or you could write it as a percentage. So multiply that decimal by 100 gives you 66.2%. So a confidence interval is just like with means. It's just going to be the sample proportion plus or minus some sort of margin of error. The margin of error is calculated as a z-critical value times the square root of the sample proportion times the complement, or Q, over the total sample size. Now, this will be something, this margin of error and the z-critical value, basically all of this will be done automatically for you in the graphing calculator. So you don't have to worry about that. If you're trying to basically figure out what is the margin of error with your actual confidence interval, that's simply going to be the largest value in your confidence interval minus the sample proportion, and that will give you margin of error. And this is basically, the confidence interval is basically the probability that the confidence interval contains the true population proportion. So if you're doing a 95% confidence interval, basically you're 95% sure that the true population proportion is between X and Y. If it's 90%, you're 90% sure that the proportion is between X and Y. So when you're constructing a confidence interval, identify what's your sample size and how many people fall in that particular category that you're interested in looking at. And from there, calculate the actual sample proportion, which is p hat. What you should do after that is verify that the sampling distribution for the proportion can be approximated by a normal distribution. The way you do this is you take the sample size and multiply it by the sample proportion, and do the same thing, sample size times the complement. And if that multiplication for both of them is greater than or equal to 5, then you can basically say you can approximate this distribution as normal. And for the homeworks, you can actually skip this step because we wouldn't give you something where that wasn't the case. But that's how you would go about checking to see if you can actually do a confidence interval proportion. Find the critical z-value that corresponds to a given level of confidence. And in this case, you can use a normal table, but honestly, use the graphing calculator. It's going to do that for you. It's not going to tell you directly what the critical value is, but you don't really care. You just really need to figure out what the confidence interval actually is. Find the margin of error, which there's formula is right here, but like I said, you can figure that in the calculator as whatever the maximum data point is in the confidence interval minus the sample proportion. It's a lot easier to do it that way. And basically, step 6, find the confidence interval. But the calculator will do that for you. So let's go back to that problem. In a survey of 1,000 U.S. adults, 662 said it's acceptable to check personal email while at work. So let's make a 95% confidence interval for the population proportion who say that it is acceptable to check personal email at work. Let me close this or minimize this PowerPoint so I can bring up the graphing calculator here. So let's turn our calculator on. We'll click the Stat button, go over to Test, so arrow over twice, and we're going to go down until we see one proportion z interval, which is kind of far down. It should be A in your calculator. So one prop z int is one proportion z interval. We'll hit enter. And basically all they need to know is x and n. So in this case, how many people said it was okay to check their email at work? That's the 662. And n is how many people were asked, 1,000 people. And C level is the confidence level expressed as a decimal. So 95% is 0.95, so we can leave that alone and just hit calculate. So basically, we're 95% sure that the true proportion of people that think it's okay to check email at work is between roughly 63.3% and 69.1%. And I express those as percentages. Now, if you want to know how many people, excuse me, not how many people, what your margin of error is here, let's take our largest data point, 0.69132, and subtract the sample proportion, which they're telling us is 0.662. That's that p hat right there. So we have a margin of error here of 0.02932. And that's how easy it is to do a confidence interval. All you need are basically x and n and the confidence level, all of which are typically given to you in a problem. Now, one of the things that might happen in the homework is they might say to you, in a survey of 1,000 U.S. adults, 66.2% said it is acceptable to check their email. So sometimes they give you the percentage as opposed to the actual number of people that you're looking for. So what do you do when that happens? So let's go back to test and go back to the one prop z interval. Okay, so let's say they gave you 66.2% and they gave you the sample size, but they don't give you x. So you can just type in for x as the percent they gave you expressed as a decimal, that's the 66.2, times the sample size, which was 1,000. And when you hit enter, it actually calculates x for you. Okay, so if, for example, let's say they give you a scenario and they say 75% of 500 people check their email. So you could say 0.75 times 500 and hit enter. Okay, and that's your new x value. So that's how you get x. If they never tell you directly the number of people that represent x, all you have to do is take the percentage they give you and multiply it by the sample size. And that's literally all you have to do for the confidence intervals for proportion.